So before we get started, up at the top here, your test is going to be on 7.2, 7.3, 7.4, and 7.5. So there's no questions from 7.5 on the review, but we just had a homework assignment, though we did some of them yesterday. So make sure you know how to do questions from 7.5 as well. So do not forget about 7.5. You're not going to have any questions that have to do with graphing, so you can cross these two out. Don't need to worry about them. But we will have one question that was from the material on our last quiz that we took that has to do with our interest. So for these types of questions, we use our A is equal to our starting amount times 1 plus our rate to the power of t. So we have to figure out what our starting amount is, our rate, remember in decimal form, and our time. So your starting salary at a new company is $37,000 and it increases by 3% each year. What will your salary be in 10 years? Round your answer to the nearest dollar. So what is our starting amount? $37,000. What is our rate? Awesome, 0.03. We take 3% and move our decimal 2 places this way, so 0.03. And then what's our time? 10. So plug everything in. We have A is equal to our starting amount, so 37,000, times 1 plus R, so 1.03, to the power of 10. So when we put this into our calculator, make sure you follow your order of operations. We need to do 1.03 to the power of 10 first. So we get A is equal to 37,000 times 1.34391. So we're going to keep that in our calculator and multiply it by 37,000. So our answer is going to be 49,724. It says round your answer to the nearest dollar, so that would be whole number, but it's 4.9, so we could round to 25. Remember, rounding's not that big of a deal. If you put 24, totally fine. Or if you put 2.49, still fine. If you're off by a couple dollars, no worries. But if you're off by like $100, then that would be a problem. All right, so we're doing the even ones. Let's take a look at number 6. So we are putting this into exponential form. This one's a little bit tricky because it doesn't give us our base here. What's our base when it's not written?
10.
10. So when we put this into exponential form, we always start with the base. What would our exponent be? Zero or 1? Which one? What's our exponent?
Is it 1?
So we start with the base and then we switch these two. So the 0 is our exponent and then that's equal to 1. So let's look at number 8. We start with our base, which is 14, and then we switch these two. So what would come next? What's our exponent?
2.
2, and then that would be equal to 196. So always start with the base, and then just switch the position of the other two. Any questions on these? All right, let's look at number 10. We're rewriting each equation in logarithmic form now. So log form has to have a log written in it. We start with the base, just drop it down, and then switch the position of the other two. So what's our base going to be? 14, and then 196, and then that's equal to 2. Any questions here? All right, let's look at 12. So we start with log. What's our base? Our base is 3. And then what comes next? $243, and then that's equal to what? 5. Awesome. Any questions from this section? All right, next we are evaluating the expression. So we're going to say this is equal to some value x. Now, we can't figure out what logs are in our head, but we do know what exponents are. So how can we put this into exponential form? What's our base? 7 to the power of x, because we switched these two, and that's equal to 343. Now we're going to ask ourselves, 7 to what power is 343? We know 7 to the first power is 7. 7 to the second power is 7 times 7, so that would be 49. 7 to the third power would be 7 times 7 times 7, so 49 times 7, which is 343. So what's x equal to? Three. Perfect. Any questions on this one? All right, let's look at 16. So log base 7 of 49 is equal to x. Put it into exponential form, so we have 7x is equal to 49. So 7 to the first power is 7, 7 to the second power is 49, which is what we're looking for. So what's x equal to?
7.
So if 7 to the second power is 49, what would our exponent here have to be?
2.
2. So x is equal to 2. Any questions from this section? On the test, these will say evaluate each expression without a calculator. Meaning I need to see your work. Can't just put this in the calculator. I have to see your work. All right, let's look at 18. Here we are condensing each expression into a single logarithm. So we're bringing it all together. Anytime we have a number out front, the first thing we want to do is move it up top. So this 3 in front of our log, we need to bring it up top to the w, so it'd be w to the 8th power. To the 3rd power, oops. W to the 3rd power. We just take the 3 and bring it up top. Now we want to condense it. So if we are adding, what goes with addition to condense?
Subtraction?
No.
Multiplication?
Multiplication. So we're just going to multiply everything together and we're going to write it as a single log. So our log and our base stays the same and we only need one of them. Everything else, we're going to multiply it together. So u times v times w to the 3rd power. And that would be our answer. You'll probably see it in parentheses like this, but it doesn't really matter Could write it without or with it, as long as you have everything being multiplied. That's the important part. To condense, you multiply. Any questions here? All right, let's look at 20. So again, we're condensing it. So what should we do first? Awesome. We bring these numbers up top. So we have log base 6 of x to the 6th power minus log base 6 of y to the 5th power. What do we do next? To condense, what goes with subtraction? Division. So log base 6, which goes on top? The x or the y? X. The first one always goes on top. So x to the 6th power over y to the 5th power. And that is our answer. Any questions from this section? All right, next we are expanding. So 22. So first thing we want to do is take this 5 and bring it to the front. So we're going in the opposite direction we were when we were condensing. Now we're breaking it all apart. So we bring this 5 to the front. So we have 5 log base 7 of x, y to the 6th power. Now here we are multiplying x times y to the 6th power. So to break it apart, what goes with multiplication? Addition. So this would be 5 log base 7 x plus every single time you break it apart, this goes with it. This goes with it. So log 5 log base 7 of y to the 6th power. And then one more step, we need to take this 6 and bring it to the front. What do you think we do if there's already a number there out front? What are we going to do to that 5 and the 6 that we're moving up front? What happens? So we multiply. 5 times 6 is 30. So 30 log base 7 of y. So this is our answer. So if ever you have like two exponents out front, you just multiply them together. Any questions here? All right. 24, we're expanding again. So here, whenever we see a square root or a radical, we want to change it to an exponent. We know the cubed root, let's say the cubed root of x, is the same thing as saying x to the 1/3 power. We need to change it to an exponent, that way we can take our exponent and move it up front for our logs. So this is like saying log base 6 of 5 times 3 to the 1/3 power times 7 to the 1/3 power. Because both the 3 and the 7 are underneath, so they both get that 1/3 power. Now, what goes with multiplication to break it apart? Addition. So we have log base 6 of 5 plus log base 6 of 3 to the 1/3 power plus log base 6 of 7 to the 1/3 power. What else do we have to do? What do we do with these exponents? What do we do with the exponents? Bring it to the front. So we have log base 6 of 5 plus 1/3 log base 6 of 3 plus 1/3 log base 6 of 7. So you guys good with this section? Expanding? Alright, we have two more. We'll do 25 and 26. So use a calculator to approximate each to the nearest thousandth. So on the test, it'll say to the, like, round it 3 decimal places. So you don't have to worry about hundredth, thousandths, whatever the difference is. It'll be specific on the test how many decimal places it wants. So when we put this into our calculator, we have to do the change of base formula. So we have the log of what over the log of what? Which goes on top? 22. The one that's already up high goes on top. The one that's down low stays down low. So we need to put the log of 22 into our calculator. And we get 1.342422, and then the log of 4. We get 0.602059, and then we just divide. When we divide, we get 2.229. And that's our answer. Any questions? All right, last one. We have log base 2 of 10. So what goes on top? The 10. So log of 10 over log of 2. If we put log of 10 in our calculator, that is 1. And then log of 2 is 0.301029. So 1 divided by that would give us 3.322. If you put 3.321, totally fine. It's all good. As long as you're just a little bit off, but not too far off. Do you guys have any questions about anything for your test tomorrow?